Everyone. Let me get my screen shared. There we go. And so it's we're getting near the end. We got 2 lessons left in Math 21, Introduction to Statistics. We are near the end. We're working on Chapter 12, and Chapter 12 is on 3 populations proportion tests. And in 12.1, we did the goodness of fit. And recall that was, do the observed values match what we expected for multiple populations? What is expected based on the proportions? And 12.2 does something a little bit different. 12.2 also has 3 or more populations. But within each population, each group has more than one setting, or more than one tier, more than one category. And so what we end up doing is we end up making a table. 12.2, this is the chi-square test for independence. Independence. And what we're trying to determine, the data is organized in a table. With categories across, or populations across the top. And subcategories making up rows. And what this test checks is, are the columns / populations independent of the individual categories, or dependent? Dependent. Okay. So guess what? It can always be organized in a table. And quite frequently comes as a table. The data is given, or are given, data is plural. The data are given in a table format. So what we want to have is, in the first column, we're going to put our row labels or subcategory labels. And columns, since there's at least 3 populations, we're going to have at least 4 columns, maybe more. This is summarized data for the populations. before the groups based on subcategories. And I know you guys have seen it. It was on the midterm. It was, are you a sophomore, freshman, junior, senior? Do you like pepperoni? Do you like sausage? Do you like cheese pizza? We had a table. And what this boils down to, the H naught always, always, always says row and column variables are independent. And the alternate hypotheses is there is some dependency. There is some form of dependence between the rows and columns. I bet if we did a table and we asked people for multiple age groups, do you like broccoli or asparagus? Children predominantly are going to say no. Every child I know didn't like it. I didn't like it. No one I knew liked it. But as I grew up, I began to like it. And so if we made the categories, the groups, age ranges, and the response is, yes, I like asparagus, no, I like asparagus, the rows, there is some dependency on how old I am and whether or not I like asparagus or not. That's the idea here. What we're going to do in Statcrunch, since this is a table or done in tables, it's going to be stats, tables, contingency, and we've seen contingency before, way back in chapter 5. And we're going to do with summary. And the things it's going to ask us a variety of options. So pause and finish writing that, and then I'll list the options it gives you. In fact, maybe we could load it up. I'm going to load up data sets. And let's see, I've got my data sets. So the data set we'll have is Jones Hefe, CH 12.2 contingency table. Is the data set in Statcrunch. And if you don't remember how to find that, let me click back and do it. When you click on, let's go back to home. Here on data, you click data sets and you type in the search words. So we had Jones, FA. I think I might be able to just go with contingency table and see what pops up. There's the data set, and we can open it up. And let's just look at that table and talk about our options: stats, tables, contingency with summary. So the first box it says, so Statcrunch boxes, and what do I choose? What do I select? So in the box that says select columns, here we want to highlight or select all the columns that don't have row labels. because the very next box is row labels, and that's where we're going to tell it where to find the row labels. Select the column with the labels. Okay. Display is the final box we're going to do a lot with. Expected count is our go-getter. It's our go-to one. We will use row count, or I'm sorry, row percent. Column percent. And I'll illustrate that in just a second. Because it's very much how this comes into the conditional probability or conditional distribution. Sometimes they say frequency distribution. Okay. And some problems might ask for contribution to chi-square. When we have this selected, each box shows what it gives to chi-square, our test statistic. Okay. I'm going to come back over the problems. Now, I know the first question in the homework asks you this. You're not going to do it, but maybe we should discuss it. The first question asks about expected frequency. When you're working it out by hand, this is row total times column total divided by table total. Like our chi-square test in 12.1, like our goodness of fit test, all categories should have frequencies greater than or equal to 1. And the other one we had was no more than 20% are less than 5. Or we could say this another way, at least 80% are greater than or equal to 5. It should just be less than 5. And let's look at our first problem. First example, if you load the data set, it's already in there. I put it in there. Example 1, this is in lecture notes, page 153. And this is the money, health, love problem. It says 883 men and 893 women were asked if you could only have one of the following, you could only choose one, would you pick money, health, or love? And the data is stored in the table. Like such. I'll reproduce it here for the lecture notes. We've got gender in the first category, and we've got men and women. The first category is money, health, love. We've got 82 and 46, 446, 574, 355, and 273. The total for the columns, there was 883 men, 893 women. Okay. So let's go through the steps of the hypothesis test. It says test the claim. Oh, I'll write that on the next page. Test the claim that gender and response are independent. At alpha equals 0.05 level of significance. Okay. For these chi-square tests for independence, H naught is always row and columns are independent. To be particular in this problem, gender does not influence choice. And choice doesn't indicate gender. Nor does choice indicate gender. Or affect gender. It seems like that's a little funny. Gender is the fixed one. I'd be more prone to say the men and women are the categories here, but they are really subcategories because the three groups. This is a 3+ population. The three groups are people that like money, health, and love, and do the responses depend on gender? HA, our alternative hypothesis, is they are dependent. Which means gender and response affect each other. Seems more like gender affects response kind of thing. So that's step one. Step 2 is identify alpha. We're given alpha is 0.05. Step 3 is our Statcrunch. We're going to do stats, tables, contingency with summary. And if you've already loaded the data set that I had up there, you can start working with it right away. If not, you may type it in. Notice I have the category labels at top. Gender is the row label category. Then we had money, health, and love. And I typed in the row labels here. So I'm going to go into Statcrunch. We're going to do tables, contingency with summary. My row labels are money, or I'm sorry, my categories, my populations are money, health, and love. My row labels are in gender. And I'm going to click on expected count. This tells me chi-square is where they save value. That's the test statistic right there. 36.84 to 2 decimal places. And my p-value is less than 0.0001. We compare that with alpha. It is much less than that. So step 4 is make a decision. I hope you have this memorized by now. The p-val is too low. Reject the hope. Reject the null hypothesis. Support HA. HA was gender affects response, or there is a relationship, there is a dependency, or there is sufficient evidence to show that gender and response are dependent. And remember how I told you the expected frequency was the row total times the column total divided by the table total? If you take 883, the row for men, multiply it by the column total for money, 128, and divide by 1776, you get the value in parentheses. That's the expected frequency. So if they are independent, these values will be close. The values inside the parentheses and outside will be close. Notice for several of them, they're nowhere near. Health and love are kind of far apart. I think most shockingly to me was that even though more women were surveyed, a whole lot more men selected love as if they only had one thing. And the society tends to think that the women are the romantic ones. Doesn't sound like it. Before we go on, I want to go back and talk to you real quick about what those other options, the row and percentage, column percentages are. So we were working on money, health, and love, gender, and I'm going to do row percent first. Notice when I click on row percent, like I did here, it even says it, count is in row percent. The row percent's in the box. What they're doing is they're taking each box is divided by the row total. And listed in parentheses form or percent form. $82 divided by 883 times 100 per percent gives me this 9.29% to 2 decimal places. So that's what they're doing. When you see it in the problem, when they ask you in the problem, what they'll ask for is give the conditional distribution of responses by gender. So the way you read this is the easiest way to remember it. It'll be in this format. This by this. It's columns, or wherever this is, by rows. This tells me to do whatever's in the last one, do row percent. If I change it the other way around, give the conditional distribution of genders by the responses. This says, this is in the row, genders are the rows, break down the rows by columns. So here we're going to do column percent. And we can take a look at the difference real quick. I'll have 2 windows open. The row percent, what they've done is they divided each box by the total in the row, and they put the percents. The column percent, they take each thing in the box, divide by the column total, and give that as a percentage. So 82 divided by 128 right here times 100% gives me that 64.06 right here. Homework will ask you to list this. Homework asks for these distributions. In decimal form. Okay. You'll have to convert the percent to decimal, or manually calculate it. And we'll do an example in the homework. I'll actually manually calculate it first, and then I'll show you what response we would have gotten. All right, so that was that one. We have another fun project done by students. So the next example, a group of COS students that worked at Cold Stone Creamery felt that gender and cup size scoop cup size were dependent. Test the claim at alpha equals. Test this at alpha equals 0.05. We have female, male. Like it, that's the small. Love it, that's a medium. Gotta have it is a large. Everyone's gotta name something different. Starbucks gives 3 different ways of saying large: tall, grande, and venti. Well, no, venti's 20, but the other ones are variations of large. And they found 105 females wanted the small, 63 males did. The medium size, they were similar in ranking, 79 and 86. The large ones, 54 women wanted it, and 150 men wanted it. Now, looking at it, it looks like as the cup size gets bigger, more men want it and less women want it. I'm thinking there's a strong case argument for dependency right here, but let's follow the procedures that we've learned. Does this meet the criteria? Is every category bigger than 1? Yep. Are any of them less than 5? Nope. We're good. So, H0. Remember, row and column are independent. Which means in this case, gender doesn't affect cup size. Or serving size is a better way. Not everybody puts it in a cup. You might get a waffle cone or something like that. HA for the chi-square test for independence is always they are dependent. And that means gender affects serving size. And you could look at it the other way. If you only saw what people ordered, knowing that men like more large cups and women like small ones, you could argue that if you didn't see the next customer, but they ordered a gotta have it, in all probability, it's a guy, not a girl. We were given our level of significance. Alpha equals 0.05. We'll put this stuff into Statcrunch, which I've done already. Like it, love it, gotta have it. I didn't remake a new gender column because they already had it over here. I made sure, because this said men, women, and the ice cream was women, men. I made sure the 105, 79, 54 corresponded to the women, which was the bottom row, and the men were the top row. We'll do stats, tables, contingency with summary. We are like it, love it, gotta have it is our column. So the row labels are in gender. Let's just look at expected count. We see chi-square is 49.69. The p-value is less than 0.0001. How does that compare to alpha? It's less than it. So we reject H0, support HA. There is enough evidence to show a relationship between gender and serving size. at Cold Stone Creamery. Maybe it's different at Baskin Robbins. I doubt it, but they only checked one Cold Stone and it was actually only one particular one. Okay. If you want to see something else, there's another option in this thing. Let's just edit this one. The percent, contributions to chi-square. I told you about it. When they ask you about it, see chi-square is 49.69. They go through, there's a formula for calculating it, but it looks like the one that's contributing the most to chi-square is this one, women in the gotta have it size. And then next is women in the like it size. In fact, the men had less of an impact than women across the board, which is interesting to me. But that's where that comes from. If you click on percent of total, what they're doing is they're taking each category, like this 63 for men that like it, and they're dividing by the total. 63 over 537 is 11.73%. Okay. Let's take a look at some examples from the homework. I mean, you couldn't open my course. Nope, that's not the one I want. Let's do that one, why not? So from the homework, 12.2, I want to look at 5, 6, and 7. Wow, again. Why not? Okay, let's try this again. My math lab. I'll sign in. Maybe let's grab a different student course. Let's try the evening one. There we go. So I'm going to go down to assignments. Look at 12.2. We're running out of sections, aren't we? Almost done. 12.2, let's take a look at number 5 first. So researchers found 400 current smokers. Actually, no, you should practice doing this because you guys learned this part. Let's do number 6. That's a refresher. I want you guys to refresh on that. We did that the very first week of the semester. All right, so here's an example where they give us all the data. 36 randomly selected students who dropped a course was conducted. A survey of 36 students were conducted who dropped a course. This is what was collected. They recorded gender and why they quit. Maybe the course was too hard, there was personal reasons or work reasons. They want us to construct a contingency table for the 2 variables. One thing you can do is go through and count the totals. So part A, we could hand count the totals. But I don't want to do that. Let's load this into Statcrunch and we're going to do stats, tables, contingency. And this is one of the few times we're going to have with data. We don't have a summary of the values. We have each person's response. Stats, tables, contingency with data. My row variable is in we got to look at the way they wanted it on the table. On the table, the rows were genders, so that's what we're going to put here. Rows are gender. And that means column variable. Is it called response? What was it called? No, reason. For now, let's just do expected count. If we need something else later on, we can come back and edit it. These are the values right here. Notice this is male, female. This is female, male. Pay attention to that. Note, because I did this earlier and I'm like, why is it wrong? I wasn't reading the problem. They changed the order. Note Statcrunch put the rows in the wrong order. So what I'm going to do is I'm just going to take those values and I'm going to plug them in to the answer. Female or male was the bottom row. 3, 6, 6. Female was top row. 9, 9, 3. Okay. What's the hypothesis? H0 always has, for this chi-square test for independence, independent column and rows for H0, and the columns and rows are dependent for HA. Chi-square was given here. So I'll write it over here. And I've got a p-value, 0.157. .703 here. .157. Now, did they give us an alpha? Tested at alpha equals 0.1. The p-value is still bigger, which means we do not reject H0. We do not support HA. So we've failed to reject H0, and that's because there's not enough evidence to do so. Both B and C say fail to reject. B says there's not enough evidence. Now it says for part C, oops, conditional distribution of drop reason by gender. So we had male, female, course, personal, and work. Here, gender is the row, rock reason is the column. This is column by row. We want each row to have 100% at the end. So what I'm going to do is I'm going to go up to the min. How many total min did we have? 3, 6, and 6 is 15. This is going to be 3 out of 15 because there's 15 males. This is going to be 6 out of 15. This is going to be 6 out of 15. For females, there is 9 and 9 is 18, plus 3 is 21. So there's 21 girls. So each of these categories is divided by 21. I know 3 over 15 is 0.2. This is 0.4 and 0.4. I don't know the other ones very well, though. I think it's 42 on this first one. Close. How many decimal places did they want? 3 decimal places. The 3 decimal places is 0.429, which means that one is. And this is 0.143. Notice, so each of these values rows adds to 1. The other option I have for doing that, it's column by row. So we could change this to do Statcrunch, tell it to do row percent, because that's what the last thing was. So let's look at this by row percent. Min was 20% or 0.2, 40% or 4.4, 40% or 0.4. This to turn to a decimal is 0.4286. To 3 decimal places is 0.429. And you'll notice if I click check answer, I have it. So it's doable by hand. And note, if you do it and it says you're wrong at first, what you should really do is go back and check. If you do it like the row percent, make sure you didn't grab this row down here. It's really easy to just grab extra parts. Make sure you got the right values in the right spot. And now what do they want us to do? Choose the correct bar graph, and it's broken down into male and female. So the personal and work height for men should be the same height, and it should be the tall one. That's A. Does that match with the females? Females is the second group. Course and personal, C and P should be the same height, and work is about third as tall. That looks like that works. Okay. Here's an example where they don't give it to you in a table. So 12.2, number 7. No table given. So we got to pull out the information we want. In a randomized placebo-controlled study, 1,017 healthy women 45 years of age or older were randomly divided into 2 groups. Group 1 received 100 milligrams of the drug. Group 2 received a placebo. So let's say group 1 is drug. Group 2 is placebo. The women were monitored for 10 years to determine if they experienced a cardiovascular event, such as a heart attack or stroke. Of the 503 in the drug group, so let's see. It says 11 experienced a heart attack. So maybe we'll say the first column is heart attack, and there was 11. Then obviously the other answer is not a heart attack. And we have a total. 11 experienced a heart attack. There was 503. In the placebo group, 17 experienced a heart attack out of 514. They don't give us this information, but we can work with it. How do I fill in this gap? Well, the 11 and this number need to add to 503. The other way is we can subtract 11 from that, 503, and we get 492. 492 didn't have a heart attack. And placebo, 514 minus 17, looks like it's going to be 497. Yep. Okay. So let's see what they're asking. I just made the table real quick. What is the population being studied? What is the sample? The population are women 45 years of age or older. Healthy women, and it's all of them. All healthy women 45 years of age or older. And take the drug or think they're taking the drug. That B. Whether they have a cardiovascular event or not, sounds like that's just extra. Let's see if that's all they want. No. So let's see, there's the women who take the drug daily. There's women in the study who, all healthy women who don't take the drug daily. That's the other part of the population. There we go. So take it or don't take it. What is the sample? The samples are people that experienced a cardiovascular event when they take the drug or they don't take the drug. And it's not all healthy women, it's just the women in the study. The women in the study who, the sample is the women in the study who not take the drug daily and the women in the study who do take the drug daily. It's just the women in the study, not the whole population. So A was all healthy 45-year-olds that take drug or don't take drug. Part B was women in the study who take the drug or don't take the drug. The response variable is whether or not they have a cardiovascular event. The response is yes or no. Yes or no is not a number, it's qualitative. It's not a quantitative number thing because it's not a number. Okay. So C, response is cardiovascular event or not, and it's qualitative. Oh, that was B. What are the treatments? They gave one group drugs and one group placebo. Drug and placebo. Type of experimental design is this? It is randomized, but it's done in blocks. Some are in a placebo group, some are in the drug group. Wait, what? Not match pairs, because they're different. That's a bad question. So completely randomized design. How does randomization deal with the explanatory variables that were not controlled in the study? Well, like maybe what they eat, how much they exercise. We don't know those possible reasons for having a heart attack. So by randomly applying them to drug or placebo, there's some of each group, like bad eating habits, bad exercise habits. There's some in both groups, and it's random. Let's see which ones. C. Those lurking variables should be dispersed between the two groups because we don't know where they're at. It's the one that said equally dispersed in it. Now it gets tricky. Look at what they did. Let P1 determine whether the proportion of cardiovascular events in each group is different using a two-sample z-test for comparing two proportions. Part F, when you read it, says do a two-proportion test. Well, H0 for a two-proportion test is the two proportions are equal. And they say determine whether the treatment group is different. That's the one where HA should have a not equal sign. And they are very particular. They call P1, that's the drug group. P2 is placebo group. We're going to need that, I'm sure, in the next part. But we want, they're equal for H0 and they're not equal for HA. That looks like B on mine. Determine the test statistic. So we'll load up Statcrunch. They said do a two-sample test for proportions, stats, proportion stats, two-sample with summary. And this is the number of people that had a heart attack. So what do we have? Group 1, 11 people had a heart attack out of 503. Group 2, 17 had a heart attack out of 514. The hypothesis test is already set up well. My z-stat is negative 1.09185882. The p-value is 0.2749. I don't know how many decimal places they want, so I'm writing them all down. 2 decimal places, negative 1.09. The p-value to 3 decimal places is 0.275. Now, did they give us an alpha at 0 equals 0.05? The p-value is bigger than alpha. So what do? We do not reject H0. We do not support HA. When we don't reject H0, there's insufficient evidence. For me, that's A. G, notice in G, now they're saying do the chi-square test for homogeneity of proportions. The chi-square test for homogeneity of proportions is another name for the test for independence. For the homogeneity of proportions, sorry. The same thing as test for independence. So I need this table again. I need to enter that into the table. My table's right there. I've got group, I've got event, no event. The groups are drug versus placebo. 11 experienced events, 17 there. 492, 497. So we're going to go stats, tables, contingency with summary. Event or no event is my groups. My row label is the group. Expected count. And it gives me a chi-square. You guys see the p-value is the same? Is that coincidence? I wonder. What is it doing here? And neither of those are the same thing. It's not supposed to be P1 and P2. Let's go back to that one now. That problem messed up. G should be independent or not. It looks like it glitched. To 3 decimal places, what did we get? I have it right over here, 1.192. And my p-value is again 0.275. Again, the p-value is above alpha, so we're not going to reject H0 because there's not enough evidence. For me, the first two are do not reject H0. B is the one that says there's insufficient evidence. And literally, the only difference between these two sentences is one says sufficient, one says insufficient. It's just 2 single letters. You have to be careful when you're reading these. You have to go slowly. Square the test statistic from part F and compare it to the test statistic from part G. So part F, what did we have? That was our Z-stat. So H, it says square Z-stat. So negative 1.09 squared. They had us do 2 decimal places. I wonder if I would have put the whole thing in, how close I get. Put the whole thing in. Because I got it written down right there, right where my cursor is. 109,18582. When I put the whole thing in, I get 1.1921543. It looks like we're off by a single value way down the end of the road. 192, 192, 154, 154. This was a 4, this was a 3. And I'm betting it's because I don't have the full p-value that was, I have what it just showed on the screen, that was it. The square of the test statistic was roughly equal to the test statistic from part G. That looks like B is applying. And it's the only one that says it, they're roughly equal. Let's go with the first one they gave us. They wanted us to use 1.09. Let's try that one. How many decimal places do they want? 3. 1.188. So they're roughly equal. So on a 2x2 contingency table, chi squared is approximately Z0 squared. And that's it. So it was a long question, and that's why I wanted to go through it with you. We got a lot of steps there. But part of it, they throw you off a little bit, and they have you go back and do a 2 proportion test. So don't let it trick you. All right. That will be the end of this section. I got one more to do. I'm going to do it tomorrow morning, and we'll have everything up posted. And then I can start getting to work on my algebra and trigonometry students. I got some stuff to do for them too. Peace. I hope you guys are following along. Hope you guys are doing the homework. Don't give up. We're almost done. Hang in there.